Okay, so let's say you have um, let's just do some basic explanation of what ln is. So ln is basically log of base e. So if you have log of base e, you basically have ln, or natural logarithm of that. So which is just x. So now let's just do some, when you multiply, let's say you have ln of x times y. This is basically ln of x plus ln of y. And same likewise, if you have ln of x divided by y, then this will give you ln of x minus ln of basically y. And now the third one, if you have ln of x to the power of n, this is the same as ln, I just write ln of x plus ln of x plus ln of x, like n times. Okay, so this is the same as just n to the n in front, n times ln of x. So you already know this. So it's a simple rule. You just put that one, the n in front. Okay, and now let's say we have a different one. So we have ln of x to the power of -1. This is simply as just this is just an example from this one. So just -1 ln of x, and yeah, that's it. Yeah, that's just basically negative ln of x in simple words. And then what else? Okay, let's say you have a function now. Let's go to derivatives, because I know it gets very confusing when it comes to like derivatives or deriving the ln functions. So now you have d over dx of basically ln of x, and that is just given by 1 over x. Okay, now let's generalize this thing. So we have the derivative of the ln, and then we have an inside function of ln, which is just fx. So its derivative will be given by, see, that's the second bracket is a mistake there. Its derivative of ln of fx will be given by f prime, which is the derivative of the original one, divided by the original one. It's always like this. So yeah, so how do we let's say now there's two rules that comes from this principle. Let's call this principle 1 of ln. So if we have fx equates to u and v, and now we apply ln on both sides, we have ln of f of x equates to ln of u. If we apply this rule here, rule number 1, on the top part, we have just basically, because we put ln on both sides, let me just put u there before I skip a step. So it's just v there. So we apply ln on both sides. If you look here, that's very, very ethical. So we have ln now of f of x equates to, now we just simplify this part, so it's just ln of u plus ln of v. And now after that, we can have we can just start deriving, so we can apply the derivative of that function, so to this whole function here. So we'll have f prime of x divided by f of x, and then this will simplify, and then and this one will be u prime divided by u. That's the derivative of that part, and the derivative of this part will be plus v prime divided by v. So you see how simple the derivative of ln is. And now on this side we make f prime the subject, so it becomes f prime of x equates to the original function times u prime divided by v, and then it's plus divided by u, and then it's v prime divided by v, the original one. And then now we just simply put in uv here, and then it is times by u prime over u plus v prime over v. And now we multiply this one in there to simplify it, so that's just f of prime of x. Okay, now we have f of prime of x. This will give you, so the first part, the u will go away, so you have v u prime, and the second part the v will cancel with that v, so you have u times v prime, and now that's your final answer. So this one is known as the product rule. So if you want to find a derivative of a function of this function, you use the product rule. We know it because these things are basically multiplied together. This function u and function v multiplied together. So now let's say we have a function that is divided. So we have f of x of u divided by v, or u. Actually, I usually write it as the other way around, so it is basically u divided by v. And now we apply ln on both sides, so we have ln of f of x, and then equates to ln of u over v. Now we simplify this thing using the second rule, which is here. So we're just going to use this top part. So this part will still equates to ln of f of x equates to ln of the top part, which is u, minus ln of the bottom part, which is v. So now we have these two functions multiplied together, which is a very simplified form of the whole thing. So we can simply now just derive them. So we just write the derivative at the top and then the original function at the bottom equates to ln of u, the derivative of it will be u prime, and then this is divided by u minus. Remember, it was positive here, now it's just minus, and then it is just ln, v prime divided by v. And now to make f prime the subject, you simply have to multiply by the original function and then put these ones in the bracket, and then this is minus u prime v, and now you have that. So you can easily fast forward later and you see that here you get u over v, and then you get u prime over u plus that's minus u prime over v. It's v prime over v, and then it's this simply equates to f prime of x. Okay, so now the final answer here that you will get is that the first part, this one, the u will cancel with that u, so you have u prime, and then the u prime, it is times by what? This is still v, so you still have that v here, and then it is you're done with this first part, and then you go to the second part. That v and that v will basically equals to v squared divided by, or times by the uv prime. Okay, now this is equals to f of x. So I'm just gonna go up here and write this whole, just continue with this method up here. So we have now we do addition there of those guys, or subtraction. So you have u prime v squared. This is basically f of prime of x. So it is minus u v prime v divided by v cubed. And now you can take v out, so you have v open bracket u v, which is u prime, minus u v prime, and then this is divided by v cubed, and then this is still f of x, f prime of x. So f prime of x will give you now a simplified version of this thing. So it's v minus that 3 there, so it gives you v squared. So you have u prime of v minus u v prime divided by v squared. So this is the quotient rule. Quotient don't know if the spelling is correct, but it looks like that. Rule. My pen is lagging because it's been running for quite some time now. Okay, so now these are the product and quotient rules. So on the next video, I'll be doing some examples on how to differentiate the functions such as these ones. If you have how to recognize them and how to differentiate them. Thank you for watching this video. That was all for this one.